Hey YouTube, so this is a video about MPPSolar and my experience and essentially how I built my own solar system through the learning process. I want to just give you a couple of pointers if you're trying to build on your own. It's just a fun project if you have interest in that. This whole thing started because of this beautiful car, which is my Chevy Bolt. I love it. It's a full electric car. I easily get about 300 miles on a charge on it. It's getting to the winter now, so maybe a little bit less. But nevertheless, after a while, I figured I gotta find myself a project, and my project is this solar project. So on a weekend, I installed 4 solar panels. Each one is about 255 watts. So it should give me about 1 kilowatt of power. The reality is that where I'm situated and with the sun in my area, I'm getting about 800 best case scenario for a short period of time, and in general I'm getting about 4 maybe 5 kilowatt hour a day. It's a beautiful sunny day today, so I'm probably going to get that. So about the setup, so essentially those panels are right now connected, every the two on the right and 2 on the left in a series, so basically giving me 48 volts. It's actually more than 48 volts because each one is doing 37 volts open voltage. So essentially this is getting itself to around 60 to 70 volts when everything is cranking. So on the pole itself, which is a little bit of a big installation, I shouldn't have done it that big. But basically I have a little box. There are 2 bus bars that can support this load, and then it goes through a little pipe that goes all the way to under the ground to the wall in the back of my garage. There is a breaker here. I actually used an AC breaker, which is not the best thing to do, but I rated it for about 5 times more than what I need in terms of amperage and voltage. So it does work. I will probably replace that in the future. I just got today a DC breaker instead, and I'm probably going to replace that. The cabling, and this is the biggest thing for me that took me a while to figure it out. So like I mentioned, this is connected in series between every 2 panels. So overall it's 48 volts that's coming out of here. All the way down to here I'm just using the MC4 cables, which are rated for it's a 10 gauge or 12 gauge cables. They work just fine, and for this voltage and for this distance it should be perfectly fine. And then all the way down here I actually chose to use a 2 gauge cable, which is a little bit of overkill, but hey, it wasn't too expensive. If you're choosing cables, that's typically, it can become very expensive depending on your distance. So the best advice I can give you is that if you have a long distance, and I'm probably going to put more panels right there after removing some of the trees, but if you get into a significant distance, raise your voltage. I'm doing 48 volts here, but I would definitely do double that or even more if you can. If your charge controller can support that, then the MPPSolar definitely supports that. So 2 gauge underground, it's about 20 feet, so it's again an overkill for 48 volts, but that's where we are. The MPPSolar, this is a fantastic investment. It's a little bit expensive, but if you do the math and put together, the fact that you need an inverter, you need a charger, and you might even need to charge the batteries from AC. Let's say you have, you drain them and you have no way to start it up. Then this gives you all that functionality in one device. So overall, it's really not expensive if you consider all that. It gives you a pure sine AC output, so you can connect anything you want to connect to it. And what I've done here is basically connect the batteries one time, which is a nice thing when you have an inverter and a charger. You just connect it one time. You don't have to have cables to the inverter and cables to the charger, to a set of 6-volt batteries that are running in a series to create 24 volts, and then every 4 are in parallel with the other 4. I wish that this would be a 48 volt, and I wish that this device would support, but right now they don't have that option in the US. So if you want a 110 output, you know, because your utility is 110, you unfortunately have to only use 24 volt batteries. I wish it wouldn't be the case. I contacted them, maybe they'll do something about it. Nevertheless, it's an excellent device. And what you see here is the connection to the batteries. I used 1/0 gauge cable, and unfortunately I had to reduce it because the MPPSolar will not accept a 1/0 gauge cable. So I put a breaker here, which you see is a 200 amp breaker, which will receive here on this side 1/0 gauge cable, and output here just a 2 gauge cable, which is can't see here in the video, but it's significantly smaller, and it does accept that no problem. The plus tends to heat much more than the minus. You know, the plus itself is actually a 2 gauge cable. Maybe I'll replace that in the future. It just needs to travel a little bit longer distance, and I didn't want to buy that expensive cable. You know, after running it even at 60 and 70 and 80 amp, nothing gets hot. Definitely not the black. The minus cable and the plus cables get, you know, lukewarm. So it's fantastic. From the wall here coming the solar cables, the 2 gauge cables that I mentioned coming from the solar panels, they're coming down to another breaker, which I will replace as well. I don't really like the connections that they have here. I prefer those connections. So I actually have one coming in the mail, and I will replace that. And this one doesn't even accept more than a 4 gauge cable. So unfortunately I had to reduce it from 2 gauge to 4 gauge. And connect it, but it's okay because this is not running more than 20 amp, and you know, I'm just, you know, overkilling here, typical thing. The AC coming from the inverter, sorry, from the MPPSolar, is running all the way here to a little outlet that I put together myself, rated for about 20 amp, but I'm not using 20 amp. So it's a 12 gauge cable here. You don't need more than 12 gauge for AC. AC is not that, you know, it's also higher voltage, and it's also alternating, so it doesn't get hot. That's the reason you're running AC for long distances, and you're not running DC for long distances. Batteries, I mentioned the 6 volt batteries, and there's a little PC here. This is a stick PC. I got it on Amazon. It's about $35. It's the old version of it. I don't need more horsepower than that. It is connected to power, obviously. It's just a little 12 volt. I can connect it directly to the batteries, but I prefer not to. In case, you know, everything goes down, I lose power, I still want to have control. And then it's connected via USB to the MPPSolar. And the interesting thing that I've done here is basically take all that information that goes into that PC and present it on a website, which I'll show you in a moment. And that's really the magic here. The end goal here is to basically plug here my car charger, which is right now lying on the floor, not very nice. And I am capable of charging my car every day for about 4 or 5 hours. About 80% of the power is coming from solar and 20% from the batteries. So every once in 2 days, I'm capable of charging for 4 or 5 hours. If you do the math, I'm getting about a kilowatt an hour, maybe a little bit more than a kilowatt an hour. Charging my car for 5 hours, so about 5 kilowatt hour. I'm doing about 300 miles on my battery, which is about 5 miles per kilowatt. So if I have 5 miles per kilowatt and I'm charging 5 kilowatts, I'm getting about 25 miles a day charging my car, which is about the commute that I have to do. So it's pretty cool. Of course, every once in a while I have to charge my car, you know, to you know, 80 to 90% or 100% if I'm going on a long trip or something. But overall, this is a fun project, and you know, I'm able to charge my car. Is this economical? Probably not. If you look at the amount of money I invested and all that, it's not that economical. But nevertheless, that wasn't the goal. The goal was to just enjoy and learn about solar and electricity, which I knew nothing about it when I started. One more thing I want to mention about the batteries, you know, those are 24 volts connected batteries. So like I mentioned, 6 multiplied by 4. However, when you pumping a kilowatt 0.3 to AC, you're actually pumping about 1500 watt from the batteries because of 10% or 8 to 10% of a loss on the way. So they do tend to heat the cables, so make sure you have very good cables. And like I mentioned, this is a 1.0 gauge, which is again might be an overkill, but if you put your hand here when everything is running at 60 or 70 or 80 amp from the batteries, it is lukewarm, if even that. Then of course the black cable, the minus, is not even warm at all. So the next thing, I'm going to show you the website, and this is the cool stuff about this.
Okay, so this is the website I was referring to. Essentially what I had to do is I had to inject the thread to the watch power application, which you can get from MPPSolar. It's a good application, but it's kind of like, 1990 design. Also doesn't give you information over time. There are graphs and whatnot, but they're not interactive. There's a lack of aggregated information, which is important for me. So basically what I did is I injected a thread. That's how I can enjoy the application. I can go and change configuration if I need to change configuration, but also it will send information to my website. And again, if you're interested in how I did that, let me know. There was a guy on the web that I got the idea from. He implemented that using APIs, but that occupies the USB port, and I can't use the application while I'm doing that, so I had to write something on my own. Not too complicated, but if you want, let me know. So the website, essentially what you see here is right now I'm drawing 900 watts from the MPPSolar. This is AC output. I am actually charging my car now. What you see is that 717 watts out of the 900 and something are coming from directly from the solar, which is kind of nice. And another 268 watts are coming from the batteries. So the nice thing about the MPPSolar is it does give you a direct access to the solar through AC conversion, of course, but it doesn't store it in the batteries and then pulls it out of the batteries. So it's a much, much better way to do it versus charging the batteries all the time with some MPP charger and then drawing the power from the batteries. Over time information appears here. You can see that today 1.53 kilowatt hour came from the sun. Some of it went to the batteries, and some of it actually went directly to my car. Here, 0.31 kilowatt hour went directly to my car. But I needed a little bit from the batteries in order to support the car power requirement, because the solar panels that I have don't produce enough. So 0.14 kilowatt hour did come from the batteries during today's session. If you add those two numbers together, you typically get how much the system produced, or the MPPSolar produced today in terms of output, mainly to my car, because that's the only thing I'm using it for. But it's not 100% accurate. The reason I'm saying that is because there are losses when the batteries are drawing above a certain amperage. It does have some losses and heat in conversion AC to DC. So over time, you will see a little bit difference if you add those two numbers, and you can actually see it now. It's a little bit behind, which kind of makes sense. More information, you can see that I peaked today at 12:21 p.m. in terms of the maximum sun that produced power from the solar panels. The maximum was 717, a little bit higher than now. It will go a little bit higher at about 1:30 p.m. today, which is roughly what I've seen from the previous days. And you can go back a day here or any day and see what the status was. Information over time of wattage, you can see. And also an interesting information, which was something that I was looking for. I couldn't find any other application. It's basically how much really I am, how many hours I'm actually, producing power from the sun, which is significant power, not, 1-2 watts, but above 100. And 100 is configurable, of course, but above 100 watts, I actually had 2.7 hours today worth of sun, which is cool. Voltage over time, of course, this is a 48 volt system, but the solar panels are producing more than 48. Actually, the open voltage is about 74. So about maximum of 75 volts you will see here during a day, and the gauges are reflecting the maximums that it will draw. For example, this is maximum 1 kilowatt because my panels don't draw more than 1 kilowatt. Right now, we're not charging the batteries. I'm actually discharging the batteries to support the load that the car is looking for. So now there's 0 amp coming from the batteries. Earlier on today, I did charge the batteries, as you can see here. and as soon as I charge the car, the battery is no longer charging and actually discharging. This is the battery capacity over time as well. Again, not a very accurate information. It's relying on the voltage of the batteries, which is dependent on the load on the battery. So it's kind of nice to have. You can see here that as soon as I plug in my car, it plunged to 44 volts when before that it was, sorry, 44% when before that it was 62%. So of course it's not accurate. I'm discharging my batteries at 10 amps. This is a 24 volts, so about 244 watts. And again, information over time. So that's it. You can, if you're interested, like I said, I can add you to my website and show you how to actually inject the thread. I can just give it to you, and you inject it, and you display information on my website or on your own website, whatever you want. I just wanted to share. I was looking for that information on the web, but I couldn't find it, so I actually wrote it myself. That's it. Thank you.